And then hide these things. Okay.
Good. Okay. All right. Good afternoon, everyone. Thank you for being here. Thank you, members of the public, to come. This is a public lecture, and I think we have a few folks online. So thanks for those who are online. This is a public lecture to talk about the U.S. Virgin Island coast with a special emphasis on St. Croix. Tonight we have a large group of students from around the world, including the US, who came to the territory to look at, to better understand boulder movement, whether it's caused by hurricanes or by tsunamis. And my colleague, Ronald Cox, will provide a fair amount of background and explanation of what this whole field of study is all about and why St. Croix is or was chosen to for this camp, for this training, field training event. And then I will talk a little bit about some of the work that we've been doing in collaboration with the BNR at CGTC to sort of understand the evolution of the coastal environment of the Virgin Islands. So without much further ado, I would like to introduce you to Ronald Cox. He's a professor of geology at Williams College.
All right. Good evening, everybody. So Greg and I are tag teaming this evening to talk to you about understanding our coasts, observations of changes and impact in the USVI. And Greg put together the slide with the logo of ISROC, which I'll explain in just a second, and then the four institutions that are providing the leadership for this program that we are running here. And the ISROC, the Inundation Signatures on Rocky Coastlines project, which is funded by the National Science Foundation, has as its aims trying to investigate long-term records of extreme wave events, and in particular to try and think about ways that we can distinguish storm deposits from deposits that result from tsunamis. And we also have a very strong emphasis on connecting researchers. This is a very young field. There's not a lot of work has been done in it so far. And there are individuals working in various places of the globe. And one of our aims is to try and bring people together and then to compile data from the literature into databases that anybody can access. Yes, sir?
Apologies. There's a bit of an echo online. So if you don't mind, maybe go to the next screen. And then when you change slide, you just tell me to change and I will change my slide, your slide.
Okay.
You need to step away from the microphone, please.
Step away from the microphone. I've been set to your locks. Okay, can you hit next, please? And so here's a picture from day before yesterday, or maybe it was yesterday, of the field school in progress. And we have 24 young scientists here, everything from first year undergraduate to senior graduate students, and from all over the globe, the US, Ireland, the UK, Australia, Japan, China. There are Ghanaians in the room. They were from everywhere. It's a marvelously diverse group. Go ahead. And we've been working on thinking about some of the ways that coasts are changed. I'll talk a little bit more about the specific stuff we're working on in just a minute. But there's a whole bunch of things that can act to change coasts, right? So this is my Coastal Change 101 slide. Gravity, hillsides can fall down. Hydrology, and Greg will speak a little bit more about this. That is that simply water running off the slopes or through rocks into the ocean can affect the way that rocks behave and can engender change. Sea level can rise. That's what it's doing right now for the most part. But of course, at other times in history, it has fallen, and this will either drown or expose land. And then my favorite, the waves, right? This is storms, more rarely tsunami. These erode material, they deposit material, they move stuff around. So my focus is waves, and that's what I'm going to primarily talk about tonight, but we should just always bear in mind that these things are operating in conjunction with all of these other factors, right? And wave impacts, of course, are important to coastal communities.
You're clear, back of the mic.
I'm clear?
Yeah.
Huge.
Okay. So wave impacts are important to island communities in particular for obvious reasons. You're absolutely surrounded by coasts and you're always within spitting distance of the ocean. And this is from a study that was done by a number of institutions, including the Caribbean Green Technology Center, where Greg is a faculty member, and they put together a report just last year in which they estimated the coastal vulnerability for the US Virgin Islands in particular. And if we look at St. Croix, since that's where we are, the island of St. Croix is found to be more vulnerable to coastal hazards. This is a quote directly from the report, than St. Thomas or St. John, because it has the most extreme wave climate on all of its coasts. And I'll show you some data for that in a minute. Except the western coast. And this island is experiencing relatively high levels of coastal erosion. And Greg will talk a little bit about how that is manifesting in the present time. But what you're looking at here is a map of St. Croix, where the coastline is color-coded for for how much at risk it is for erosion, from 1, the yellow, and there's not much of that, where the vulnerability is low, all the way up through 5, the red, and you can see that there is quite an amount of that. So this is also from that report, and this is a very nice graphic that shows the vulnerability to wave attack in the USVI. And so I'm going to just make that legend a bit larger so we all can read it. It doesn't matter. We don't need to look at St. Thomas. So the red colors are the average of the average value of the top 10% most powerful waves. Blue is average of all waves. And then the width of the arrow is scaled for the power of the wave energy, right? So fatter arrows more powerful. And the direction of the arrow is the wave approach direction. So if you look at St. Croix, it's getting it in all directions and from all sides, right? And the arrows, if I go back, are substantially larger, fatter than those for the other islands. So obviously it's storms that generate the biggest waves. This spaghetti diagram here from NOAA's database is hurricane tracks from 1851 to the present time. That's the limit of our record. And right here is St. Croix in the center of the screen. And so you can see that it has been crossed and crisscrossed and near missed by bunches and bunches of hurricanes over time. And with a shorter time scale than the hurricane, there was or there was not a hurricane, we have buoy records that can help us drill a little bit more into those wave energies. And so what I've shown here is a map from the Army Corps of Engineers Wave Information Study data portal. And right under where it says US Virgin Islands, that's St. Croix. And there are 4 green dots here that are 4 of the very many buoy locations that are involved in the wave information study. And I'm going to focus in on this one here and show you some data from it. So the table has a lot on it here. There's only a couple of points that I want to make. The 4 stations are listed there in the left-hand column, their latitude and longitude, where they are. The depth of water, so these are all sitting in quite deep water. These are in meters. If you think in feet, then you can just convert those to yards and you're in the ballpark. And we have the main columns that I want to focus on are these 2. The mean significant wave height, I'll explain in a minute what significant wave height is. And so that for this area ranges from about 2 meters to 2 meters, right? So the average wave height, the average significant wave height is around 6 feet. And the peak significant wave height, as recorded at these buoys, ranges from about 7 to about 11 meters, okay? We won't worry about the wave period. That's just how long there is between individual waves. So here's our mean significant wave height, our peak significant wave height. So what the heck is significant wave height? So significant wave height is a term that's used to try and estimate the mean storminess, the experienced storminess of a sea, of the ocean at any point in time. And so it's not the average of waves, but it is the average of the tallest third of the waves from a set of data taken over some specific amount of time, right? For these buoys, it is, they're taking readings over an hourly period. So what that looks like, so all we have here is a frequency diagram, right? The number of waves on the y-axis, the height of those waves on the x-axis, and we have a whole bunch of different kinds of waves. You can calculate the average, and you can see the average of this distribution is way down here, sort of in the smaller size. So what you do to get the significant wave height is you just take the largest third of the waves, this black line at the bottom, and you get the average of that, and that is what we consider the significant wave height. And the key point here is that when we look at the significant wave height, we think about these being the biggest waves, it's the average of the largest waves, right? But there are much bigger waves in the spectrum, up to twice the significant wave height. Yeah.
Are you available for questions?
Absolutely, yes.
So the interesting thing was the period was 9 seconds.
Mm-hmm.
So if it was a wind generated wave, it'd be in the 4 to 6 second range. At 9 to 11 seconds, these waves are all coming from much farther away.
So these are, so the periods for storm waves are commonly like 10 to as much as 15 seconds for the very large. So what you need for that is a very large fetch area and a maximum sea state, and you can generate waves with that kind of period.
Right.
And you need to remember, we're talking about open ocean. The buoys are very far from the coast here. So we're talking about Atlantic type waves.
Mm-hmm. Good question. Okay. So these big waves can become further amplified as they approach steep coasts, and they become quite difficult to measure. This is not obviously the Caribbean. This is the Skerry of Aitchiness in the Shetland Islands, close to Storm Roberts Field area. What I want you to focus on here is this highest point, which is 39 meters. Here is the same Skerry in a storm, and there's that same point. So you can see that there are waves that are almost reaching the top of that Skerry. That's 40 meters. You think that's cool? Try this, okay? So here, the yellow arrow shows this house. The blue arrow is the top of the Skerry. There's the chimney of the same house. Whoopsies. And there is the point of the Skerry, right? So we have this absolutely enormous wave that is way overtopping the Skerry, a very rare event, an even rarer photograph of a rare event. They're very hard to photograph. They're extremely hard to study. And so we rely on buoys to give us some sort of measurement of what's going on offshore. And as I'll get to in a few minutes, we rely on the left behind evidence to tell us something about what might have been happening onshore. So getting back to these data, how often do these waves occur? And when we say this is the peak significant wave height, how many of those are there in any given period? So coming back to the same station, what I did was I pulled all of the 250,000 records that have been collected at that buoy since 1980 and plotted them on a frequency diagram. And you've got what I've got down here is the wave height in meters, and I have did I label that? I think I labeled that. I label that very cleverly. And now that's not working. Oops. Okay, this is now misbehaving. Excuse me. There we go. Are we now in business? Why is it not advancing? All right. On with technology. Okay, now we're working. Okay, so there's the wave height and how many records there are. And if you can see, so we've got a really asymmetric distribution, and we know that there's ones up here, but you can barely see that at this scale, right? So if we blow that up a little bit and just look at the larger ones, well, we can see the big ones a little bit better here. If I just look at, the 100 observation scale, you can see them a little bit better. And now I'm just going to select them. And so of that 250,000 observations, there are 38 that are anywhere close to the maximum significant wave height. And it turns out that all of those 38 observations occurred during 4 hurricanes, right? So if we take a 40-year record, we've got 4 storms that produced these very high waves. That means that we have a decadal average recurrence, okay? But those 4 storms all occurred in a 10-year period. It was Hugo, Marilyn, Bertha, and Lenny. And so all of those waves, the largest waves that are in the USVI buoy record, are from these 4 storms that all occurred within 10 years, right? So again, this idea that we can calculate statistical recurrence intervals, but those are only statistical probabilities. And in fact, we can have things happening much more frequently than that. And there haven't been waves of that magnitude recorded since 1999. So although Irma and Maria were enormous and destructive storms, their wave heights did not reach this magnitude. So briefly to point out that tsunami are also large wave events that are even less frequent than these storms, but obviously are very devastating. And the island is very prone to them. And this is the tsunami preparedness map showing the evacuation routes and all of that. I'm not going to talk about tsunami, except to say that obviously these are very powerful forces that also can do lots of work, right? So to understand the histories and the probabilities, and I stole this slide from Roy Watlington, who talked to the group last night. So I just took a picture of his screen and pulled this up. To understand the histories and the probabilities of these big wave events, the storms and the tsunamis, we need to find lateral archives that will go back further than the 40 years of wave buoy records or the 150, 170-year record of whether there was a hurricane or not. And large boulders are an important kind of record for that. And we get these coastal boulder deposits that record extreme events worldwide. There's a picture there from the Bahamas, from Malta, from Japan, from the Philippines. Here is a boulder ridge in Eleuthera in the Bahamas, and there's a couple of people up there on it to give you a sense of scale in terms of how high up it is. And all of those are wave in place. And then we have them here on St. Croix as well. This is of the West End near Ham's Bluff. And here's Andrew Kennedy next to a couple of these boulders. Because of these boulder sizes, and often because of how far inland they have in the past very frequently been interpreted as tsunami deposits. So people would look at these, try and date them, and sort of think, okay, now I'm creating a tsunami chronology. And the argument that has been used is that only tsunami, and this is from the Tohoku tsunami, are capable of doing work of that sort of magnitude, and that storm waves simply, even if they get very big, they're not long enough period. They don't have enough sustained force to be able to do the kind of work that a tsunami would be able to do. But we have discovered, and this is a photo by Andrew Kennedy, who's one of the group leaders, that we have recently been able to do before and after measurements and observations of the impacts of storms to show conclusively that boulders of the scale that previously had been assigned solely to tsunami are in fact categorically being moved by storms. This is one. How heavy was this one, Andrew? Oh. It's heavy. Okay. The next one I can tell you exactly how much it is because I measured this one. So this one here is 620 tons, which is about the same mass as 6 blue whales. And it just, it formed by falling off that cliff behind it. But it also got moved by waves. So here's a picture that I took in 2013, and here's a picture taken from the same point in 2014. It didn't move very far, but it moved, right? And it was just one of many thousands of boulders that moved during that event. So this magnitude of movement, before we were able to observe it, would have been attributed to a tsunami, right, and not a storm. So we've had to recalibrate the way that we think about these large deposits, these high energy events. And what becomes important now is trying to understand them more clearly and to go so that we could go back into the rock record and start to peel things apart. And Anegada in the British Virgin Islands has a very interesting record this paper was published not too long ago, several years ago, based on boulder occurrences. Here, Andrew Kennedy again, and this is a quote from that paper. So here are some large boulders, a few meters in length, now sitting there in the vegetation in the middle of Anegada.
And clearly from the reef offshore, because they have coral heads in them, and they are obviously of fairly modern extraction, modern geologically. They were able to date these and to determine that they had been extracted from the ocean, as it says, I'll get the date wrong if I try and remember it, in the centuries before 1500, right? So these have been here for a very long time. And the question is, was it a storm or a tsunami? And so one of the points I'm trying to make here, probably not very eloquently, is that we are trying to figure out ways, and the work that this group is doing this week on the island is part of that effort, trying to figure out ways to characterize these deposits, to understand them, to find clues, tricks, methods to be able to distinguish between storm and tsunami deposits in the past, so that we can build out these records, so that we can figure out ways to understand the chronology of major events at various locations around the world to help the communities that are living there build policies and plan forward. And I will hand it at this point over to my colleague.
Thank you. So this is a picture of us at Hams Bluff. So for those online, especially the Tomian, Hams Bluff is on the northern side of St. Croix. And as Rona was saying, we spent a fair amount of time in the field, just looking at those boulders, taking measurements, and do some preliminary calculation of, what type of force could move them. So this is one way to sort of understand the past or understand the impact of a particular storms. There's another way, which is much simpler, to just look at, what's called high watermark. So this is Andrew Kennedy again in 2017, holding here, looking for signs of something marine that maybe Hurricane Maria, took and lifted and deposited, inland, to get a sense of how far the waves and the surge went. So this is him holding a piece of corals. I was also doing the same. A few of us were doing the same to sort of hunt for clues. And so we created this map that you can see of high water mark caused by Hurricane Irma on St. Thomas and St. John. So this is St. John, for those who don't know, this is St. Thomas. And then this is St. Croix. And so we have, a high water mark between 3 to 6 feet all the way to 21 foot, especially on the southern side of St. Croix. So this is another way of sort of understanding the impact of a particular storm. And again, once we know the elevation, we can sort of back calculate the surge, the waves, and sort of do better numerical modeling for future storm events. So talking about the hurricane, this is Rona talked to you about waves and how most of the big waves that we happen in the Atlantic Ocean were created by, hurricane back in the 80s. This is the sort of storm signature of Irma and Maria, where red colors represent very, very powerful waves. So the storm went south of St. Croix, so very, very powerful wave going all along the south of St. Croix, and the storm sort of veered and went off to Puerto Rico, as you very well know. And then on St. Thomas, most of the powerful wave occurred here by St. John, and then the storm went up and hit Miami. But we also had some very powerful waves along the coast of St. Thomas. So this is important to know. And so then the question is, okay, if we can model those waves, can we model the surge? Can we estimate the height? Does it match observation? For in the future, like I said, better understand what's happening. And, this is the consequence, right? The consequence is, if you don't plan accordingly, if you don't know the type of storm and the type of impact that hurricane can have, it can, damage a lot of coastal infrastructure, right? So some of those pictures are around Sandy Beach. This is, I forgot the name, always forget the name, the restaurant on the east side of St. Croix, and then the top pictures are for St. Thomas. So this is the consequence, right, of the storm, or the structures that are way too close to the shoreline, where we have, this is the road, the picture of the road that I showed you. And so you have an overwash of the sand breaking down, lifting the road, breaking the road opening the pond to the open ocean. This is on St. Croix. Before the storm, there was a beach, nice white beach all around. After the storm, you can see now this beach is gone. It's still gone, but you can sort of see the strength of some of those storms in terms of impact. And I'm not gonna show too many pictures, mostly because I know that some of you are still, recovering mentally from some of this, so I don't want to dwell on it. I'm just sort of showing some of the coastal impacts, right, of the storm. Again, the beach has been completely eroded. Some of the gut, which is a way of talking about rivers in the Virgin Islands. So the guts opened up to the ocean. One thing that is interesting about this side is that not only you have the sturge coming here, but you also have a gut flow. And so you have river flooding plus storm surge, creating very high water elevation along the coast. And then here again, Duncan's Reef, I remember the name of the restaurant, an aerial view to kind of show the destruction all around the beach, right? One thing that is interesting, the position of this structure. The structure is very, very close to the water. The structure used to have a dock. You can see the remnant of this dock, completely gone, but the dock used to, be, and there used to be some sand. So there's a few questions, right? The first question is, what is the impact of those storms on the beach? Will the beach recover? But there's also a question about development. Those structures were impacted tremendously by some of those storms. And so those are two important questions that we sort of need to keep in mind of how did we build and how can we protect ourselves from, different type of storm when they occur. If we look at the beach and the evolution of the beach, so this image is Megan's Bay, that's in St. Thomas. The green line is the pre-hurricane shoreline. The brown is post-hurricane shoreline, just a month or two after the hurricane. And then the blue line is in 2020. And what we see is that there's been some erosion of the coast, especially where we have different type of guts, where the guts sort of open up the beach, and so the shoreline shifts a little bit. But a few years later, the shoreline comes back to its original position. This is Maho Bay on St. John, same thing, a lot of erosion, and then the beach sort of builds back up to its original position. This is Sandy Point, slightly different story. We have pre-hurricane, hurricane 2020, we continue to erode. But if we look on the other side of Sandy Point, we have pre-hurricane, erosion during the hurricane, and extreme accretion after. And as we move north, we hardly see any sort of changes in the shoreline. So those hurricanes do impact different type of beaches, do erode a fair amount of beaches. Did I have the same example? Okay, do erode a fair amount of beaches, but the beaches are dynamic. They can recover, right? They evolve, they move. So what about the structures? What about the amount of destruction that we've seen? And what I'm starting to see is that we didn't develop well. We didn't develop well at all in territory, right? So this is again on the southern shore of St. Croix. Sometime in the 80s, these people built those condos. I think it was a hotel, built some groin to try to trap some of the sediment. And we can see through time, especially after a hurricane, the continuous degradation of that coastline. Those groins are really not doing what they're supposed to be doing. Why? Partly because they're not really taking into account the different type of processes of sediment transport, right? Sediment can move along the shore, it can also move cross-shore, especially if you have large hurricane. And the big thing is that this structure is getting closer and closer to the water, right? So one question is the shore eroding? Is that a wave problem? Or do we have a development problem where we build maybe too close to the shore too often and modify the shoreline in ways that ultimately impact us as, human? So this is Brewers Bay on St. Thomas. For those who know, This is the airport on St. Thomas. So this is in 56. You have Modest Airport, nice sandy beach all around here, and then a bit of a wetland, which is still here, this wetland, and a bit of a gut or road. The airport is being built and expanded. All of this becomes rocky. The sand sort of starts to move a little bit. Overall, now we have a nice sandy beach from around here all the way to almost the airport runway. And all of this now is rocky shoreline. The waves are more quiet. There's used to be big corals, now it's mostly seagrass. The wave climate has changed, and the reason is not a hurricane, it's not climate change, it's human development, right? We do what we do does alter what's happening along the shoreline. This is Hovenza pre-construction, big mangrove here, a lagoon, big sandy beach, and then all of this was destroyed or damaged or reconfigured to build the refinery. The refinery was built in the 60s. By the 70s, it was completely built. We have now all those structures that prevent this longshore sediment, the transport of sediment. We also have all these structures that prevent any type of sand or any type of sediment that some of the guts were supplying to the shoreline. If you read some of the old reports from the 70s, a lot of people talk about gut sand and how gut sand is a good construction material as opposed to beach sand. So those guts were probably providing a fair amount of sand to the beach, along with a lot of the corals moving along the coast. So these structures that are now acting almost as groin or jetty-like structure prevent the movement of the sediment along the coast. And so the refinery is over here. The red line is the 1954 shoreline. And now you can see the 2022 shoreline on top, completely changed, completely modified, right? So the coastline is now changing, readjusting itself to the environment. In some location, in many locations, we are losing a lot of the coastline. In some of the locations, we are gaining some of the coastline. This is Carlton Estate. So that's further south along the shore. This is the 1954 shoreline in red. And then you have the image of the 2022 shoreline. So you can see the huge amount of erosion that has happened over the course of the years. Some of it might be due to Hovenza. But what's interesting to me is that one thing that has also changed between 56 and now is sometime during the 70s, they built the highway. And for those who remember the highway before they built it, there was basically no drainage. All the water was just going wherever the water wanted to go, right? It was just pouring everywhere. And one thing that is interesting is that right after, a few years after the construction of this highway, this wetland started to disappear. And talking to a lot of people, there were just this gut is not flowing the way it used to be. So some of the construction of the Hovenza maybe have led to the disappearance of this wetland. Construction of the highway, change of the local hydrology might also have caused the disappearance of the wetland, along with all the beaches that were on the south shore of St. Croix. So this is the picture of the house now. We'll talk about this house in a second. This house is about to basically fall into the sea. There is evidence, a lot of evidence of landsliding. And once the soil falls into the, at the bottom of the bluff, waves take it, move it away. And so you basically have an irreversible erosion of the, I think I missed a slide. There's a slide missing. Oh, sorry, it's my bad. I didn't explain it well. So pay attention to this star here. So there was no structure in 1954. But in 2020, you can see there is a house over here. So this house, which is now very close to the water, is now the same as this one. So at some point during the 80s, this person built a home. This home was 100 meters, 300 feet more or less from the coast. Maybe at the time it was 80 feet from the coast. And now this person's house is about to fall into the ocean. The result for me, is a combination of lots of sand, lots of beach in front of the bluff, So now the wave can get closer and closer, as well as changing hydrology. When we go to this side, if you do, the soil is very wet. There's a lot of gullies. You see a lot of evidence of soil basically depressing and landsliding, maybe 20, 50 feet, from the coast sometime. The land is basically falling into the ocean because it's saturated when it rains. And these pictures were taken right after the rains that we had earlier this month. And we went to visit it a few weeks before. There was no evidence of those landslides. So every time it rains, every time it's been hard, especially when you have those big, long, successive type of episodes, landsliding, the waves take it and move it away. You can see the rack line is not really reaching the bluff, the toe of the bluff, but once in a while, big wave, big swash, take that sediment, moves it away. So erosion now is in some of the locations that we have, especially at the refuge that I think you were working at. There is also evidence of landsliding and, stormwater just coming and moving and eroding some of the bluff. So this accelerated erosion that we see is a combination of sediment, lack of sediment, beach erosion, mostly a lot of time, especially west of the refinery, loss of sediment, and then also a change in hydrology. But all of it is caused by development, right? All of it is caused by development. This beach here, like I said, was Thomas. We built that road very close to the shoreline to the point that we had to armor it. Once you start to armor it, you change some of the hydrodynamics, and that beach is having a harder time coming back compared to other part of the beaches, like this one here, that has come back to its pre-hurricane position. So the point that I'm making, and I'm almost done, is that the coastal resources of the USVI are under a lot of pressure, right? The beaches do what they do. Some of them erode, a lot of them are stable, a lot of them react and can rebuild right after storm. However, when we have structures, especially when they're very close to the water, they tend to stop, modify some of the local hydrodynamics, or sometimes become very endangered by the wave because they are too close, because they do not allow the system to behave the way it's supposed to. The other thing that is, so construction like this one, very close to the shoreline, where people really want the view and try to maximize the surface area of the construction, is one of the type of threats that we have, like this one and here. But another threat that is compounding is sea level rise, right? So those are picture of a road on St. Thomas where waves are now very, very close and sometimes overtopping and scouring some of the road. This is a marina on St. John, or a little dinghy sort of a pier on St. John that is now submerged. We took those pictures during king tide events, which is the highest tide of the year, just to kind of get a sense of what does it look like when water level is very, very high. And then for all the cruisers, you recognize this, the boardwalk. And as you can see from the cloud, this is a sunny day. So imagine if it rains, or imagine if there's a storm, right? The whole boardwalk would be underwater. And with time, as sea level continue to rise, we will see this water level, just standing water level, going higher and higher. And all you need is a wave or a rain event to just push and start to damage a lot of this coastal infrastructure. So why is it important, right? It's important because we see that we need to start building differently. We need to start thinking about building a coastline differently, because we have bigger threats coming from the ocean, right? We know that hurricanes are getting stronger. The waves are likely going to be larger. The storm surge is likely going to be higher. We have sea level rise on top of that. And I also showed you that up to now, a lot of the damage that we have seen seems sometimes, not all the time, caused by the fact that we just build way too close to the ocean. The law says that we need, and it's written, highlighted in blue here, so anything needs to be 50 feet from the mean low water mark, right? Or the first line of vegetation or the first natural barrier. One thing that is interesting about the law is that it doesn't give a date for when that mean low water line was drawn, right? And this 50 feet applies to the whole of the territory. As when I said, St. Thomas is not St. John, it's not St. Croix when it comes to wave. So it's not the same when it comes to wave action and how far the waves will impact. Remember the first image of high water mark, 50 feet, 60 feet inland, we found evidence of wave action. But here the law just says 50 feet. So what Zoe and some of my colleagues and students did is December 2023, January 2024, there were some big swells, all the winter storm. And we decided to look and do what we did in 2017, which is to identify high water mark all around the island. And you can see in this case, sometimes we were finding evidence of swell action 100 feet away from the shoreline. So any type of structure, even if you follow the law, any type of structure, built closer than this at those locations that 100 feet from the shoreline would be impacted, and we would, if we had similar type event like the hurricane, would be damaged, right? So one thing that we did then was say, okay, let's then look at different type of shoreline, right? Let's assume it's, let's not sort of haggle over the mean low water versus mean high water versus any type of shoreline. We do have an official shoreline from NOAA. Usually it's mean high water from 2018, 2000, and 1918. And so we sort of use those shoreline, and then from the location of our high water mark, sort of estimated, how far they are from the shoreline. What we see is that depending on the type of shoreline that you use, that you pick, the results are different, right? And we know that that's a lot of what a lot of developers sort of do in a territory. They pick a shoreline that sort of, meet their goal and say, this is my shoreline, and this is 50 feet, and I will definitely build following the law, right? But as you can see in this picture, picking that shoreline can lead to different results in terms of where your structure will be. But as you saw from the previous images, it will definitely lead to some negative impact when we talk about hurricane. So what does it really matter? What is at stake? Yes, development, and one can say, it's their home, right? It's their investment, that's their loss, but not exactly. There's another part of the Virgin Island Code that says that basically no person, firm, corporation, or legal entity shall do anything that would obstruct, prevent anybody from accessing the shoreline of the US Virgin Islands, right? But so if the problem is that if you don't have any more beaches, if there's no space between the structure and the water, what is the beach? How can you maintain your right as a citizen to have access to the shoreline? So this is against Duncan's Reef within 2023. This is the right line, this is the building. 2024, this is the right line. There's no beach, right? So as sea level rise, as we have, storms or high swell event, we will have more and more instances where we will not have any beaches, right? So this is another view looking west at Duncan's Reef. This tree here is that tree, and you can see in January 2023, there's plenty of room. January 2024, there is no room. And there are many instances where I saw many bathers being completely wet because, a big wave comes in once in a while and the swash goes up and everybody is wet. And so it's very important as a result that now that we better understand some of the coastal environment of the territory, now that we have a better understanding of our assets, now that we also have a better understanding or start developing a better understanding of how the type of waves, how the waves impact the beaches, how the beach recover, etc. It's important that we start to revisit some of those laws, especially the setback distance laws, that take into account the dynamics of the beach, the dynamics of the hydrology, how we build, where we build, how we can maintain and protect our infrastructure and at the same time ensure that we all can enjoy the legal access that we have to the shoreline of the Virgin Islands. So I hope that was useful. This is the direction we're going now. There's more that we're going to be doing in the next few years, but we're pleased to be starting. So thank you so much. And, please let me know if you have any questions.
Yeah, can you, leave it on screen share, please? And, just, can you make an announcement to the people online that if they have questions, they should?
Yeah, online, if you have questions, please put it in the chat. Nikita will, will yell them out. Yes.
You didn't mention anything about the fact that we're on a different tectonic plate than St. Thomas. And St. Thomas's plate is subducting under us, so we're having a lot of earthquakes
What's in Croy?
all over the Caribbean, but
Oh.
particularly between St. Thomas and St. Croix, we're having.
Yeah, St. Thomas has more earthquake than on St. Thomas. That's St. Croix actually, because a lot of earthquake that we have now are coming from the places that are north of the BVI. But yeah, we are in a very active, according to the statistics, our earthquake risk is similar to parts of California. It's just a matter of time.
Yes.
And that's a discussion for a separate discussion, right?
Okay.
But our building code is not ready for it. And that's something that I've been banging. I don't know if you guys were there in the public meeting last week about the hazard mitigation plan, but especially on St. Thomas and St. John, where there's a lot of construction on the slopes, on stilts, it's the worst type of combination possible. So, yeah.
I'll just add quickly to that, that the, microphone, Zoomers. But because the sources, those earthquake sources are close to the islands, tsunami that are generated within the Caribbean basin, you've got the travel distance is very short before they hit land, and so the warning times are very, very small, which makes the risks much higher.
Yeah, for St. Croix, you have a few seconds between the earthquake and the tsunami wave, the first wave hitting you. So as soon as you feel the earthquake, don't think tsunami, don't wait for the siren. Just start thinking about what to do. Go up. If you're in a structure, if you're in a building, don't start panicking. If you have just a few seconds, just go ahead, go up.
Thank you.
Hi, Dre. I'd just like to share information about the buffer zone, like you mentioned, the 15 feet, right?
50.
Yeah, 50.
50.
Yeah, 50 feet about the horizontal buffer zone. So we did 2 reports for the government of Prince Edward Island. There is
Jose, do you want to come up and use the microphone so people online?
I mean, just use microphone here.
Yeah.
Okay. Well, so Prince Edward Island Interim Coastal Policy Recommendation Report and Prince Edward Island 2023 State of the Coast Report. And I'm one of the co-author of each report. And one of the very important, interesting points of the policy recommendation reports was we recommend to switch the traditional, we use 15-meter horizontal buffer zone to 2-meter vertical buffer zone, because the reason is like we are very low lying, like around the shoreline, the elevation is quite low, so 2 meters vertical buffer zone can adapt to different topographies around the shoreline, like with different horizontal distance. And the reason we recommend the 2 vertical meters at the buffer zone is because in September 2022, we experienced a very severe Hurricane Fiona I think along all the east coast of North America. And at the north shore of our island, the high water marks are generally above 2 meters. So that's the reason we gave this recommendations. And definitely, as you mentioned, I believe the coastal retreat or the coastal erosion of extreme storm events is significantly greater than the ordinary coastal retreat. Like our shoreline retreat rate is 40 centimeter every year, like the average value. But we just found from one of our recent projects that just after Fiona, this one extreme event, there are over 51 square kilometers land loss around our shoreline. So yeah, just that's what we got from our recent outcomes. So yeah, just a sharing, no questions.
Yeah, so good points all around. We find that there is a fair amount of erosion, especially on St. Croix, but I think it's probably linked to the construction of the Hovenza and the starvation of the beaches and the coastline. And like I said, some of the other erosion that we have seen is caused by some of the construction that put barriers and prevent, again, movement of sand or badly designed artificial beaches that just don't stay very long. But otherwise, apart from that, we have a lot of bays and those tend to be fairly stable overall. The setback distance policies vary around the world. I think there's only one other places from my review that has that is referring to mean low water as a sort of starting point. Most places start at mean high water, and most places start behind the vegetation line, whereas we say up to the vegetation line. So the VI code is, which was built in the 60s, and it was not developed in order to protect development or provide guidance for development. Actually, that 50 feet regulation was developed to ensure access to the beach. And that is important, and that is the big question that we are now going to have to wrestle. And I think that's the difference between the Virgin Islands and all of the Caribbean islands compared to, Canada or other big country, is that hotel developers want to give immediate access to the beach to their guests. And we don't have a whole lot of landmass. So we cannot say, oh, build 50 feet, build 100 feet from the coastline because you're gonna hit, something. And then, everything will be compressed behind. And hoteliers will not be excited about this, because if we are in the report that Rona was cited, we looked at what is the real estate value along the coast. It's not too much. It's a lot, actually, many billions of dollars, but it's all commercial hotels, resorts, et cetera, et cetera. So I think that's going to be some of the tricky part to sort of think about when it comes to revising this policy. How do you balance protection of the coast? How do you balance access to the beach all time of the year? And I'm trying to go back to the last slide. And I don't know if it's even worth it at this point. But how do you, balance access to the beach? Like here, with economic development, economic incentive, and keeping, one of the biggest employers, alive. So it's tricky, but I appreciate your example, and I definitely will look at some of your thoughts, because we're going to try to adapt thoughts from different places. Online?
I can't remember. So we have a question from the Zoom chat from Don Buchanan, and he said he did not see Ronald James racetrack in the photos during the impact events on the South Shore. And he was wondering if you could elaborate on what is that's in South Shoreline.
So I don't fully understand the question. I'm gonna put the racetrack and then you're gonna repeat your question.
Yeah, so basically how Covenant's development has impacted that particular part of the shoreline.
Starved it. Starved it for sand. A lot of the sand is coral sand. Like I said, maybe some of it came from guts, but right now everything is basically corals, dead corals. And the big reef on the South Shore is, most of it is east of the refinery. And so the hypothesis or the thought is that, you know, the corals degrade, breaks, whatever, breaks down, creates sand, and then is moved along the shore. And the construction of the refinery basically blocked. And you can see here sand being blocked, moving, you know, westward. So that's, I think, one of the big questions, one of the big motivators. But like I said, I also think that the construction of the highway and some of the change in the hydrology has also an impact, especially on bluffs. There was a hand raised, yes.
All right, thank you, great presentation. Aside the setback distance you mentioned, which is a government policy, may we know if there's any policy of government in the area of hardcore coastal engineering structures, like civil defense wall, breakwaters, etc.?
So that's something that we're starting to do.
Right, could you just repeat that?
Oh, the question is that, is there any type of laws about the construction of structures? In general, my understanding is there's not, but there is a current policy from the government, which is to discourage this type of hard structure along the coast. The code only refers to bulkheads. They don't really talk about, you know, seawalls or types of structures. So that's something that we're actually working on, or thinking about, you know, working on very soon, which is to start to codify a little bit more, define different type of structures, and then maybe at some point sort of, you know, discuss if we want to put some codes around different type of use of different type of coastal structures. But right now, the sort of policy, which is not the code, is let's try to favor any sort of nature-based solution or no construction of hard structure. I don't know, John, if you want to talk about it. No.
As far as permitting, it just has to meet the international building code.
Yeah.
And that's basically the policy of the department right now.
Yeah.
But we do need to see about 100 to 200 foot setback.
Yeah.
Given, you know, your report plus many other.
Yeah.
4 inches of sea level rise since '93. Those are all factors that should come into play, and the 50-foot setback is the public access law. It's for people to be able to get access to the shoreline, and that landowners cannot stop anyone from walking within that 50 feet from low mean tide. However, vegetation and rock does shorten that 50 feet. So it's in lieu of. So if there's vegetation and rock, the property owner owns up until that point. And so that does have a conflict with the public. But the structures, they're paying a very big price, and we pay a big price because those structures are now impacting and causing problems. That house that's over on by Gwynn, Tarleton, that's a disaster, and there was a good 100 feet that's in the water of that property when it was first surveyed.
Yep.
And then he of course he lost all of it, and that's why we're looking at, or we should be looking at, a policy of not just 100 feet but 200 feet, and then anyone who's within that, you can't sell, unfortunately.
Yeah, that's a big question because a lot of people have property there.
And stop the water.
Yeah. Oh, yeah, sorry. Yeah, go ahead.
Something else which happened with Convenza is they removed all the mangroves that used to be wetlands. And they completely wiped out the entire mangrove population in that area, which was a deterrent for hurricane damage. Is there anything, John, currently about not touching mangroves on the island?
Big time. It's a indigenous, plant and it is, protected by DPNR with, $100
$100 per tree?
per tree.
I like it.
Yeah, you have to get permits to even.
That's, it's about dredging.
Yeah.
When they created a water column that was 30 feet deep, now compared to what it was before, when Crouch Lagoon was there, it was stable. But now, because of those depths and because of all that turbidity that they caused, that killed a lot of the coral.
Yeah.
And it just raised everything on the south shore west of them.
Any question?
That was more of the discussion, for example, in Spain was a bit the same problem, all the, like in the sixties, a lot was built on the coast, like for a big tourism and everything, which all the problems are starting or have started. So for example, there it's not allowed anymore, you can, so it's public land also the coast in Spain. So there, officially there's no private beaches there. And now the people are not allowed to sell anymore these properties and they're not allowed to restore them or something like that. And even some parts, of course, it's a huge discussion who will pay to the water, for example, some type of hotel complex that were built, or natural parks and stuff. It's an ongoing topic. I think in Italy they're discussing it also, so there's a lot of countries facing the same that rely heavily on tourism, but at the same time you have to start to protect your home. So I think there's a lot like globally from all the this country.
Yeah, I mean, this structure is falling into the water. So to your point, are we gonna demolish it? Like who's responsible for it? Because it's gonna fall into the water, whatever is in there is gonna go into the water. There's still, remnants of habitation with all the whatever garbage in there. It's a big problem.
Yeah, in the UK, in the south, there are some programs also that it's not allowed anymore to restore, and there, well, the wave will start to pick up on that houses. But I don't know if it's a national trust or something. There's a program. I don't know how to follow this process to make it less traumatic that this house will go on the way also. So I think that all that it's a lot of things happening and discussions and I think that
It's tricky.
it's really, yeah.
Yeah, it's difficult. And that's why I was saying the other night is like science is this amount, and then you have all the other problem around it. So finding a solution to all of those policy things is not just science. Oh, online?
We have more questions. So we have two.
Okay.
Let's do this separately from Richard McKinley. So do you see any correlation to beach erosion and the resorts / commercial on-site wastewater treatment system discharge outlets?
Not directly, hi Rachel, not directly. But indirectly in the sense that it's likely that they are damaging some of the ecosystems that help either attenuate waves or help the beach sort of replenish in terms of the seagrass and the corals. So I think it's the environmental impact on marine organisms that are probably increasing some of the negative impact of the waves.
And the second question was, how is this information in general, especially in relation to the setback distance, being incorporated into the comprehensive land and water use plan?
So the land and water use plan is gonna just mention it very briefly. There's some public meeting coming up in June about the land and water use plan by DPNR. But the setback distance, we're working with DPNR on a separate effort to just address it in and of itself.
Has there been any effort to renourish beaches with sand from elsewhere in the past? And if so, has that been successful or no?
No,
Okay.
except for the reefs. They're getting the sand from Aruba now, because the Bahamas said no more, because they're realizing that They are very low lying. Sand is a resource, a very precious resource. So Bahamas closed its door a few years ago, many years ago. So a lot of it is coming from Aruba. Rumors that Aruba is also thinking about saying no, but I need to double check that. But it's a very expensive proposition for the REITs, but they also have a very particular type of sand. No, and I think that the reason why it's not successful is because they are not following proper engineering guidelines. But on St. Thomas in particular, there's been a fair amount of relishment in front of resorts, because like I was saying earlier, guests want immediate access, kind of like you guys, you know, just a day tonight, maybe, yeah, you go to the beach, right? Because it's right there. But I don't think that because those projects last maybe 5 years, 6 years, which is, you know, very short.
Maybe,
What's that?
maybe.
Maybe, exactly, exactly. So better guidelines, and I think that goes back to the question earlier about starting to have more guidelines in the code or as policy to sort of, you know, guide people to have some form of minimum standard for design to sort of minimize some of those bad projects.
Thank you.
That's what, on the, back to the setback, distance measure or policy, was it something that the community was involved in taking the decision, or it was put down on the people by the higher authority?
So nothing has been done yet. Yeah, so right now we're just sort of finalizing some of our findings from a science point of view, just from an observation point of view. Hopefully Zoe will finish running a software in the next 2 weeks, so we can, so I'm joking, I will stop making fun of you. No, we're still crunching the number, if you will. Then we're gonna start having the discussion. We're starting to have some discussion like tonight to sort of raise the issue. So I'm glad that, you know, members of the public came. We're gonna start making more and more noise in order to do what you just said, so that it's not crafted in the dark and then we have all the problems that, you know, were mentioned before coming at us. So it's ramping up.
One more remark, it has to do with policy policy. You guys are taking into consideration the rate of sea level rise. Because if that's not taken into consideration, they're gonna set that line up and then a sea level rises, it's just gonna come clean up. So
Yeah, it's one more problem to think about. Yeah. Yeah. One more problem to think about, like I was showing to you at the end, towards the end. We start some, not all, but some structures are close to or are being inundated during king tides. So that gives us a sense that we're just gonna get worse from there. But yeah, it's complicated. We started to have those discussions with Port Authority to sort of think about raising their apron. But what about beaches and stuff like that? I don't know. It's very complicated. If you have any question about guts, we have a gut expert right here. So if you want to know about rivers and ephemerality of those, Dr. David. And yeah. Thank you.
There may still be, looks like there's some dessert stuff left. Andrew walked in with a big plate of watermelon. So, yeah, please help yourself to what remains of the